Hello everyone. With this video, we are going to start a new module on energy management in buildings. For this course content, we'll be focusing on commercial buildings. And as you can see, the topic is very much specific to energy management in commercial buildings. It is related to thermal engineering or applied thermal science, HVAC and R section of the industry, which is heating, ventilation, air conditioning, and refrigeration. We'll also touch upon the lighting part of the system. Then we have energy management related to it, and the economics and policy making and policy implementation has a very crucial role while we go through the energy management in buildings. So with this introductory video, we are going to start, and I am going to give you the course content included in this video, included in this course. But as and when alongside, if I find some more interesting topics, some more good research ideas, or some very good findings across the world, some articles, I'll keep on sharing those things alongside in between the major modules which we are going to cover. So we'll be starting with the overview of energy issue around the world, which means we'll figure out what the issue is right now. Everyone is talking about energy crisis and all. So is it energy crisis real? How much energy crisis is already there? What can we expect in some upcoming years? And then we'll see the building energy performance overview. So previously we would have expected us that the building energy is not a major part of the total energy consumption. But as we would have seen in the part one of the module, which is the overview of energy, we will appreciate and also realize that the buildings use a considerable amount of energy out of the total energy consumed in the country. That means that the transportation, manufacturing industries, in the building, commercial building, residential building, and all everywhere wherever the energy use is there, the building energy use is also considerable amount of it, which is around 15 to 20%, and that's a major chunk of it. So we'll figure out the energy performance which are related to different equipments used in the industry, and a lot of stuff. Then we'll also briefly touch upon the concept of continuous commissioning, which is developed at Texas A&M University Energy Systems Laboratory by my thesis professor, Dr. David Claridge. And all the course content which I am taking is directly coming from the Mean 664 course, which I am just completing in this semester of fall 22, taught by Dr. David Claridge. So all thanks to him for all the course content ideas and his wisdom on it. The next part is the historical methods for load calculation. That means there were energy calculations since some 1900s, but those were much simpler methods. Historical methods were much simpler because the computation was not as easier and as simple as we have access to computers and systems right now. So we'll look upon the simple methods used for load calculations earlier. Then we'll use and go through the mean energy calculations. Then we building load calculation. This is the major part of the course which we need to understand and practice a lot, where we will be calculating different building loads, which will include the transmission load, the solar load, the infiltration, the internal gains in terms of electricity and from the occupants, and some minor loads also. So solar transmission is another minor load, one of the example of it. And we'll go through more details as and when we go through the modules. Then we'll see how to model our buildings as a lump capacitance model. So you would have understood and learned the concept of lump capacitance in heat and mass transfer course. Over here, we are going to apply that concept to our buildings. So we can easily compute some of the temperature changes and the heat transfer which are occurring between the building and the weather, the outdoor conditions, much more easily with less amount of computations. Then we have modified bin method. We'll go through that, which is simplified energy analysis procedure given by SRAY, which is American Standard of heating, ventilation, air conditioning industry. Then we'll go through the equipments used, which are the energy used and energy losing equipments in our AHU, which are air handling systems. And these equipments will go through in detail for fans, coils, dampers, and valves. And we'll also touch upon the minor, small other equipments also. Then we'll go through different types of AHU, which is air handling unit. Then we will go through a specific example of how we can use all the above concepts of building load calculations and modified bin method and different types of AHU combined and make a simulation spreadsheet, which will be able to help us to calculate the heating and cooling energy consumption in our buildings. After making the spreadsheet, the model available, we need to calibrate it. So we'll go through the calibration procedure also in detail, which is also developed. One of the method of calibration is developed by Dr. David Claridge, and his contribution is so much acceptable and appreciated in the community. Then we'll go through the chillers and cooling towers, that is the source of cool water used in air handling unit, and furnace and boilers, which are the source of hot water or steam for our air handling units. That's where we would end with the hydronic loops. That means how the cool water and hot water from the cooling tower or furnace, boilers, chillers is supplied to air handling units. How are the different arrangements made? How we can ensure that there is minimum amount of energy loss and systematically supply all the required cool and hot water to the system. So that's all we have with the introduction and the list down of course content. In the next video, we are going to understand is the energy crisis real or not, and we'll go through some more scientific explanation and reasoning behind it. So best of luck. Thank you. Do comment if you are interested in this course, and see you in upcoming videos. Thank you.